All right, so dilations have to do with similarity because when you dilate a figure, it creates a similar figure. It says dilate triangle ABC from the origin by a scale factor of 1/3. Okay, A is originally at -3, 3. Now, since I'm dilating it around the origin, all I have to do is take these coordinates and multiply them by 1/3. So that means that A prime is going to be at -1, 1. -1, 1. Make sure you label that as A prime. Then we can repeat the same thing for B. B is at 3, 3. If I multiply that by the scale factor, that means B prime is going to be 1, 1. Okay, last but not least, we can write down C. C is originally at 0, -3. So if you multiply that by 1/3, right, 0 times anything is 0, -1. All right, and we will label that one C prime. Okay. The next one says find the scale factor. Okay, so this one we use the scale factor. This one we are going to find the scale factor. Okay, I'm going to list this point and its prime point, and we are going to see how the dilation transformed from the smaller triangle into the bigger triangle. So the smaller coordinate is 2, 2, if I'm talking about this point. Okay, this point turned into 3, 3. So if we think about it, 2 times something gave me 3, right? 2 times something gave me 3. If you were to solve for that something, we would divide by 2 on both sides. So it looks like the scale factor is equal to 3/2, which makes sense, right? 3/2 is bigger than 1, and we went from the small into the big triangle. And the next one, I'm going to color code some of these sides. Okay, the biggest side on this one's 20. The biggest side on this one's 16. The smallest side is 10. The smallest side is 8. And then black goes with black. We can also see the order of this from the similarity statement as well, right? AB corresponds with DE, and we see that BC corresponds with EF. Okay, we want to find the scale factor that goes from triangle ABC into triangle DEF. That means that this is getting smaller, so my scale factor should be less than 1 when I find it. Okay, so 20 times something gave me 16. You could have also said 10 times something gives you 8, or 15 times something gives you 12. But when you solve for that, 16 divided by 20, if we simplify 16 divided by 20, that means our scale factor is 4/5. Which again, if we're going from a bigger triangle to a smaller triangle, it would make sense for our scale factor to be less than 1 if it's getting smaller. Okay. Similar polygons, the basics. If two shapes are similar, then the angles are congruent, but the sides are proportional. So angles congruent, sides proportional. Keep in mind, right, that triangles sum to 180 degrees. So we're going to have to keep that fact in our back pocket. All right, they give us a similarity statement. So if we pay attention to the order of this, HI corresponds with KL. And we also know that IJ corresponds with LM. And I guess that's for both of these pictures, so I'll just color code them both right now. Okay, so given that we know angles are congruent, okay, if I corresponds with L, then we know that this angle right here has to also be 71 degrees. H corresponds with K, so we know that X has to be 53 degrees. And last but not least, right, M corresponds with J, so that would have to be 56 degrees. Okay, I know it didn't ask for all of them, but I just wanted to point that out. Ultimately, right, our answer for X is that X is equal to 53 degrees. And it all comes down to paying attention to the order of that statement. All right, so angles the exact same. Now, sides are different. Sides are proportional. They want us to find Y. Well, I know purple, I'm trying to find black. So if I do purple over black, then I need to do purple over black. We can cross multiply, so 20y is equal to, let's see, 28 times 15 gives us 420. Divide it by 20, and it looks like we found y is equal to 21. Okay, we're going to have another conversation about the importance of the order. So the only difference between these two pictures is the order of the statement. So on this one, AB corresponds with DE. But on this one, they're saying AB corresponds with DF. In this picture, BC corresponds with EF. And in this picture, BC corresponds with FE. All right, so we need to make sure that we're just labeling the corresponding pieces correctly. Okay, notice how our setup's going to be different in these situations since the similarity statement was different. Okay, they want us to find Y. Well, I know green and I know black. So that means I know green and black over here, so let's work with those colors. If I do green over black for this ratio, I have to do green over black for that ratio. When we cross multiply, we are going to get 18y is equal to, let's see, 24 times 12 gives us 288. Then I can divide by 18 on both sides. So we got y was equal to 16. Yes, ma'am?
Would it matter if you put 12 over y?
Yep, that's perfectly fine. If you did 12 over y, then you would just have to do 18 over 24. Yep, good question. All right, on the next scenario, okay, I still am working with green and black with the way that I've labeled it, but just be careful because your green and black are different on the other side. So if I do green over black, then I need to do green over black on this side. So in this case, 24y is equal to 216. Divide by 24. And it looks like y is equal to 9. All right, let's jump to the next side. All right, so we had the side splitter theorem that we worked with. The biggest thing about side splitter theorem is that you have to have parallel lines in order to utilize the side splitter theorem. If the lines are not parallel, this theorem does not apply. All right, so if the whole thing is 16 and this part is 4, 16 minus 4 leaves you with, 12 units right there. Now, I'm going to give you guys the first ratio, and you guys tell me what the other ratio would have to be. If I decided to do 15 over 12, yeah, and that's an A, but yes, that's correct, A over 4. All right, so if we cross multiply in this scenario, we are going to get 12A is equal to 60. And then I can divide by 12 on both sides. So it looks like A is equal to 5. Now, this one, you cannot use side splitter theorem. And when I was grading your tests, I've started grading this class period. I have a few left to wrap up. But some of you guys use side splitter theorem when solving for this piece when it was not allowed. Okay, notice that B is not being split by parallel lines. It is the parallel line. So I'm not allowed to do part over part equals part over part. I'm going to have to do whole over whole equals whole over whole. So if I want to talk about corresponding pieces, that piece corresponds with this piece. And then this whole side of the little triangle corresponds to the whole side of the big triangle. So again, we cannot do part over part with finding B. All right, if I decide to do the big purple value over the little purple value, then I need to do the big green value over the little green value. And as a reminder, right, the little green value is 16 minus 4, so 12. All right, so that would give you 12B is equal to, let's see, 9 times 16 gives us 144. If you divide by 12, it looks like B is equal to 12 in that case. All right, then there were two other theorems that we had mentioned in this unit. We have mid-segment theorem. Okay, the oh, yes, ma'am, sorry.
The one that we just did, why wouldn't it be 9 over 12 and then B over 16?
So that would be perfectly fine, and you would still come to the same conclusion. So I agree with that set of ratios. Okay, for mid-segment theorem, again, you have to have a midpoint and a midpoint. When you connect two midpoints, it creates a mid-segment. The relationship between the mid-segment and the side opposite of it, let's say I were to give these labels for just a moment. If I call that A, B, and C, D. Okay, two things that we know. If you double A, B, it is equal to CD. Another thing that we know that the theorem states is that AB is parallel to CD. So these are the two things that the mid-segment theorem expresses. Now, if this is 9, that means C would have to be equal to 18 units in this case. Right, then the last theorem that we introduced was the angle bisector theorem. Okay, first of all, you have to have an angle that was bisected. I know this angle's bisected because of those single arcs. I'm going to set up a ratio based on my order. You tell me what the other order has to be. If I do 20 over 9, what would have to be the other order?
16
Yep,
over D.
very good, 16 over D. Now again, that's not the only ratio you could have started out with, but if I did pick this order, the other ratio would be 16 over D. So when you cross multiply, we have 20 times D is equal to 9 times 16. If we divide by 20, it looks like D is equal to 7.2 in this case. Yes, ma'am.
Did you do 20 over 16 and 9 over D?
Yeah, so another option that we're hearing, if you did 20 over 16, then that would be 9 over D. Notice in both of these cases, it's 20 times D, and it's still 9 times 16. So I agree with that. That's a valid order. All right, my video is about to cut off at 15 minutes. So I'm going to go ahead and pause and stop it now. Y'all